in my mind here, I was sitting there thinking, when we got the maximum value, we figured it out, I thought it was just completely outrageous, but somebody Googled it, and it's true. This is an actual, this is really a no BS problem. That 8515, this is an 85. It's not made up, okay? So there's this lava fountain on the Kaluku, and what it does is that they want you to, what is the initial velocity of the lava? Remember, when we looked at the notes on the page prior, it talked about initial velocity. Initial velocity is the B value, 350. In this case, it's feet per second, okay? It's fast. What was the lava's maximum height above the ground? Now, there are two ways about going about solving that. One of which was to use the graphing calculator. Obviously, lava is going up and coming down, so it's going to be a maximum we can calculate. But if we look at this problem, it's given to us in standard form, ax squared bx and c, where our c value is 0. The easiest thing to do in this case is to not use the calculator, because we know that the lava started at 0, came up, and came down. What happens at the halfway point? The axis of symmetry, which means it's the x-coordinate of your maximum. This one is really easy to work with. Negative 16t squared plus 350, opposite of b over 2a. Negative 350 divided by negative 32. And that gives us the x-coordinate for the maximum. I think it's like 10.5, I want to say?
10.9375.
1093, okay. So I'm getting, let me show you how to do this in the calculator. So 350 over 32, and we get that decimal, okay? Now, what it's asking you to do next is, what is the height? The height here, this is after 10.93 seconds, it reaches its maximum height. So what we need to do is just substitute that value in for t. Easiest way to do that is just to use our calculator. Negative 16 parentheses, second answer. What I'm doing here by pressing, you guys ever use the answer button in a calculator? We use the answer button a lot in here. I use it all the time. It stores what was the last answer. Now, I'm going to throw that in here because I know it's negative 16 answer, and I square it. And then I add to it 350 times the answer. And this will give me my y-coordinate. So after almost about 11 seconds, the lava is now 1,914 feet up in the air. To me, that just seemed ridiculous. The Sears Tower is only 1,700 feet tall. The lava shot up and over the Sears Tower, including the antennas. The antennas at the very top are 1,700 and change. So this lava, yeah. So in basically 11 seconds of pure terror, lava shot up to the top of the Sears Tower, and then 11 seconds of pure terror after it, lava hit the ground. So the lava was in the air for about how many seconds?
22.
Roughly 22 seconds. It's like 21 and change. So roughly, yeah, so when you put them together, that's what you're looking at doing here. You don't necessarily need to graph that, but if you just think about what does that problem mean as you start it, it has a 0 value for C. So it started at the ground level. In 11 seconds, roughly, it hit its peak. 11 seconds later, it hit the ground. Does that make sense?
Pumping all over again.
Yeah, it's pumping. Does that make sense? What else do you want to look at?
79.
Which one? 79?
Oh, yeah.
You're gonna kick yourself. In this problem here, it is quite literally asking you for where does this equation roughly equals 60. We go right to our y equals table. Go to our y equals table. And we're going to put in the equation. 0.56x squared plus 0.488x plus 51. And I go to my table. I don't even care what the graph looks like. Because year 0 in this case was the starting year. In this case, it was what year? 1989. Year 0 was 1989. In 1989, there were roughly $51 billion spent on long distance. This is back when people had houses with a thing mounted on the wall called a telephone. Wow. These things actually had to plug into the wall. They had cords. Some people had things at their houses called answering machines. Answering machines were machines that had little itty bitty cassette tapes, another feature, that you could leave a message after the beep. Then you'd hear them rewind it and play. Now, fancy houses, really fancy houses, had telephones that not only plugged into the wall, but you could take it off the wall and walk around your house without a cord. They had a giant antenna that you would carry around and run into things. And every once in a while you might hear a neighbor's conversation. You had to have local and long distance carriers for two different setups. You could have, yeah. I had the Swatch phone where it was like see-through, you can see see everything on the inside. It was awesome. So if you just look through here, in 89 it was 51, 1990 is 52, 90, 91, 92, in year 4 years after the start, roughly 1993-ish, it went over 60 billion, excuse me. That's it. That's all that meant. You are quite literally looking for information in the table given the setup. So what's going to happen a lot with these types of word problems, guys, it's not so much that it's difficult to come up with your own model or come up with these things. It's the idea is, can you interpret what these things mean from the data? That's it. It's so much easier than what you guys give yourselves credit for.
It was like 3.5 hours long, I remember.
What's for year 0 is 89. 1993. Year 0, 0 is at. Yes, ma'am. We got Chris. You go by. Oh yeah. Hey guys, this is good. In Grace's table, what happened here is her X values aren't going by ones. There's a way to change those settings. If you hit second table set, and it says table start is the first option. Hers is at -7.25. And it says change in table, the delta table, going by 1, so each one of yours was 7.25, 8.25, and so on. In this case, I'm just going to change that to table start at 0 and go to 1s. What's nice about doing that is that by changing those tables, you can adjust for where you want the table to start. You guys are lucky. I didn't do this stuff by hand. All right, fine, you can use the old one. Yeah. Shut up. I mean that nicely. What else? Any others on this one? All right.
This is literally like 3 hours.
Again, in this case here, we just did that. Remember I said it was like 1900 something?
Yeah, but I was trying to figure out something.
I think it was like I think it was 1914 and change. And we actually Googled it, and that's what it was. Again, in this case here, if the pilot's landing a small airplane on a runway that's 2,000 feet long, what's the maximum speed that they can land? Well, you're looking in the table here for something to equal roughly 2,000. Now, it being a positive A value means it's doing this, which means our x-intercept is at 22.
Is this in miles per hour?
I don't know.
So just write like the number that it gives.
Feet per second, speed in feet per second. Now, if you think about what this model is saying, you have an x-intercept of 22. The reason that I know that it's 22 is that that's my c value. Your c value is always your y-intercept. It's an up like a cup problem because the a value is positive, which means it has to drop here and come back up here. It's asking for the maximum speed. Well, these are both two speed values. Which one is greater? The left or the right? Correct. So you're looking in your table then for the second time that you get close to 2,000 in that model. Or you can go ahead and set this equal to 2,000, use quadratic formula, you'll get the same answers. It works. Just using this is just quicker.
Wait, what is you said it was like the y.
Yeah. The C value is always going to be your y-intercept because if x is 0, what's the first a and b then? They're both going to be 0. Okay. And that's how that works. If, I don't know.
I got like 6 billion. I got 6 billion exact. Or I don't know. I wrote down like 3 different numbers.
I got 46 feet per second.
So it's either like 2. I got 156.
Yeah,
that's what I got.
And I just did this with you and I got 156. I got 1,985. So.
78.
What do you got, 156?
Yeah, that's what I got.
Yeah, we just keep scrolling through. We're just looking through it.
I got 156.
Now, as you, one of the things is you probably sat there and scrolled through forever to look for it.
Yeah, we did.
Now, one of the things you can do on the calculator is if we hit again where it says second table set, it says table start. Just like we did with Grace a second ago, I started her table at 0. If I know that it's not moving up fast enough, I can say my table start at 150 and go back to my table, and I can just kind of find it that way too. It just jumps and moves the table along quicker.
There is only a thing where it says max value of whatever, and then just like plug it in and just automatically gives it to you.
Yeah. No, because maximum value, this would be a minimum value. Maximum is vertex. It's not going to do that. You have to be able to interpret the information. But it's just moving the cursors around. Okay? So your what is it, 156, 157 feet per second, somewhere along those lines? Okay. I want you guys to save these things so you can keep working on in case you're still screwing stuff up. Oh, do you have a question? In case you want to come back to the flex when I ask more questions, it's fine. Okay? Remember, those last 2 questions that are on the back, I forgot to put the actual problem on there. I'll have more of those information for us Wednesday. Because between today and tomorrow, we're going to do, I'm calling a little bit of an audible. I originally said that in the email the other day, or yesterday, that we were going to, come on guys. I originally said in the email that we were going to do shaded stuff with this. We were going to graph those. Since it's the short week, I want to make sure that I spend a good chunk of time today in 5.8, and then tomorrow we can do some regression stuff on the calculators with the word problems as well, so I don't have to worry about this yet. When we come back from the long weekend, we'll do this problem before we get into comics. I think it's a pretty easy thing to start with, okay? So let's finish up and start 5.8 then real quick. Well, not finish, I should say, let's start. And what we're going to do today is that we're going to start, yes ma'am? That's a given. So let's take a look at, ladies and gentlemen, guys, I've really had it at this point with you guys in here. You have to understand that we only have 33 minutes left to go through all this material. And if I had all 33 minutes, you guys would have about 10 to start working. But the amount of times I have to stop you guys because you won't stop talking, you're just kidding yourselves. Okay? I get it, it's 12th hour, you want to get out of here, I understand. We got to focus the attention back up to what we're working on, okay? So to start this out today, we're going to work on basically writing equations of parabolas, the quadratics, in the 3 different styles. We're going to write equations that come in our standard form, in vertex form, and then in intercept form. We're going to work in those 3 forms today. So the first one we start with is vertex form. And what we're going to be able to do is we're going to be able to write the equation of the parabola or of the quadratic given a vertex and a point. So if you think about if you have a vertex and a point, in vertex form, what does the h and k stand for? Yeah, it's the vertex. So the h and k is your vertex. So if I have a vertex and a point, that means I have 4 of these 5 things in the equation, right? Which one don't I have? A. So you're going to have 4 parts, solve for the 5th. That's it.
Wait, what's the last equation?
This is intercept form. When you have your zeros, where the x-intercepts are. Let me write this out here. So we have vertex form. Bless you.
Bless you.
Intersect. And then we have standard. And they're all really, bless you. Aside from being allergic to it, they're not terrible. Okay. Let me show you an example. Vertex form. Oops. When I have vertex form, I'm working with this, where h and k is my vertex. And I have a secondary point given to me. 4 and 1. So if I have a vertex at 2, -3, and I have a point that's on the curve, at 4 and 1, oops. I now know 4 of the 5 variables. Which one don't you know? A. Substitute in and solve for A. So we have y is 1 equals A. Our x value is 4 minus 2 quantity squared minus 3.
You scroll so I can see the whole thing. Thank you.
What's 4 minus 2? What's 2 squared? The 2 and 3 are your 2 and -3 are your h and k. Okay, that's your vertex. You have 4 parts because the ordered pair is 4, 1, x, y. Your x value is 4, your y value is 1.
So you just write them like
Then it says write the equation.
oh,
So you're right. Everybody okay that a is going to equal 1 here? You're winding up with a very fast 2-step equation. You get 1 for a, but the solution is write the equation in vertex form. Y equals 1, x minus 2, quantity squared minus 3. Do I need to put that 1 there? No. If I do, is it okay? It's fine. That's it. Now, what's nice about this when we're writing these equations out today, for all the whole 9 of them that I gave you for homework tonight, you can say, you can check each and every one of them. How, you may ask? Dun, dun, dun. Y equals. If I go back to my calculator, I go to my y equals table, and I put this equation in. Quantity, x minus 2 squared, subtract 3. Which ordered pair should I see? 4, 1. And 2, -3 would be helpful too. Are they both there? What's wrong? A is like your scale multiplier. When you think about A, go back, think about linear stuff. Slope is your end value. A kind is, I want to say slope, but it is it tells you, the A value allows you to tell you the direction. If A is positive, it's up like a cup. Negative, it's down like a frown. The larger the absolute value of A, the narrower the curve is. The smaller the absolute value, the wider the curve is. That's all the A value does for parabolas. That's it. Yeah,
So for all of them, are we finding A or are
it's kind of the same thing over and over again. Yeah, it's really all it is. It's just the different forms. And that's why you just got to keep your form straight, and it's really easy to go. Try another one.
That was form is what form?
Yeah, that was vertex form. Take a second to do another one. They're really, really fast. You don't need a diagram. You don't need to know what they look like. It doesn't matter, because if you have your vertex, at 4, 3, that's in the first quadrant, isn't it?
yeah.
Now, then, if your I'm sorry, I looked at point. I'm sorry, the vertex is a 2, -1, so it's. No. I just realized I did that.
There you go.
There! I could get it right eventually. It would be there, and if the point is at 4 and 3, couldn't that be really, well, I mean, if it's here, it's tough to tell if it's going to be up or down. I mean, I'm guessing, I don't know, but if you just go through the idea that you have vertex, it's a dead giveaway. It's direct substitution. -1 is a point, I'm sorry, not, it's 3, excuse me, I'm reading these things all backwards all of a sudden today. So 4 minus 2. Hey, ladies and gentlemen, it's not always going to be 1.
Wait, how do you
get rid of the square root?
yeah.
What's 4 minus 2? What's 2 squared? Quarter box. Oh, yeah, PEMDAS. Yeah. Why, hello. We missed you. Oh. That's all it is. That's it. I'm crazy. Yay, math. Hey, Lori. Good riddance, though. Oh, man, it's like a. I don't know if we'll be here, Lori. We might fail. Intercept form. Intercept form is when you have zeros. Your zeros are your x-intercepts. It's where it crosses the axis. Your zeros are where they cross the x-axis. It's the x-intercepts. Those are your p and q. Now remember, if your zeros are at -2 and 3, that means your terms would be x plus 2 and x minus 3. Because you're trying to think about what term, in parentheses, gives me the 0 of the intercept. So if your 0 is -2, what term would, when you set it equal 0, gives you -2? Well, it has to be x plus 2. They're opposites. So again, we have a point at -1 and 2. So 2 would equal a. Our x value is -1 plus 2, -1 minus 3. If your 0 is at -2, what's the term that gets you to the -2? Well, it has to be x plus 2. That's what that has to be. Don't try to do this in your heads. You're going to screw it up. You will. No offense.
I've been doing this for like 9 years. I can do this.
Not that I don't trust you, but with a lot of these things, guys, I want you to remember, whether I give you the nice calculator or the silly calculator, both calculators have this thing on them, this button called parentheses. Use them. Don't try and do this in your head. -1 plus 2, close the parenthesis, open another one, -1 minus 3, and let the calculator do the math for you. That means this side, 2 equals -4a. What's a? Try again. What's A? Try again. What's A? Negative half.
2 divided by 4. Oh, right.
Oh.
There's your A value. There's your A value. It's substitute right in. Now you have your A value. Go back and write it out. Y equals negative 1/2 x plus 2 x minus 3. That's the problem. Write the equation of the line, or write the equation of the quadratic that has that. You're solving for A. You're solving for A over and over and over again. P and Q are your zeros. Yep. So remember, guys, you have to remember the difference between a zero and a term. The zero, your zero, take the opposite of it to get what's the term. That's how you make them work. Okay. Intersection.
Also, you don't use the vertex, you just need a
Yeah, what is that?
Yeah.
What's that X?
Or X.
I was saying that this is,
Oh, like-
if this is your zero, that's your term.
Oh.
The last one takes a little bit longer to go through. Standard form.
Great.
Standard form is when we're going to use a matrix.
Wait, on the intersection one, does it matter which one's P or Q? Alright.
Yes, ma'am.
For like X minus B, what is that called?
Intercept.
And then the first one.
Vertex, yeah. Can you put that away, please? Mine. Here's your intercept form. And then obviously standard form. Now, when you have standard form, you're just going to be given 3 sets of ordered pairs. You don't know anything else besides that. What this is going to force you to do is that if you look at standard form, you have an ax squared, a bx, a c equals y. If you have 3 ordered pairs, you know the x value and a y value 3 times. By creating a matrix, a system of equations here, what you're going to be able to do is solve for everything at once by pressing a couple of buttons. Let me walk you through this kind of long form first to show you what's happening. As we take each set of ordered pairs, this is my x, that's my y. So I'm going to write that out. Negative 1 squared a minus 1 times b plus 1c. The reason why I put a 1 there is because what's going to be the coefficient for c every time? 1. Okay? Equals 5. Very good. Then I do the same thing again. 0 squared a plus 0b plus 1c is 3. Three squared a plus 3b plus 1c is 9. Okay. What this is going to let me do is simplify out and create 3 equations with 3 variables. You could chug these things through by hand using systems of equations, substitutions, linear combinations, whatnot. Or remember, I showed you guys how to press buttons on the calculator with matrices. What we need to do is create a coefficient matrix. Move this up a little bit. So, let me start over again. What's negative 1 squared? 1. So it's 1a minus 1b plus 1c is 5. 0a, 0b, 1c is 3. 9a, 3b, 1c is 9. when we used matrices back at the very beginning of the year, and I showed you guys that little shortcut, what I asked that you guys did was create what's called a coefficient matrix. The coefficient matrix are the coefficients of all those variables. In this case, there are 3 of them with 3 equations. So we're going to make a 3 by 3 matrix. Yep. The coefficients for the first row, 1, -1, 1. The second row, 0, 0, 1. The third row, bless you. You can put right if you want. Be careful though, Hopworth. Sometimes people will mess up the -1 squared. They'll accidentally write -1 because they'll get the wrong buttons. Okay? Just be careful with your negatives. Now remember, when we use inverse matrices, we're going to go to the -1 power, and then we multiply that by our answers. 5, 3, 9.
How do you get the matrix on the
I'm going to show you.
You
Alpha zoom. Alpha zoom. And we're going to make a 3 by 3. What's that? There's a bunch of ways, yeah. Remember, when you're working with matrices, you have to make sure you use the right arrows to make all this stuff work. Alpha zoom.
And you just plug that in and it gives
Yeah.
you answers?
It'll give you the answers in terms of A, B, C as the column matrix. So you just put in 1, right, -1. Make sure you use the negative button, not the minus sign. 1. Because people say, why do I have an error? Because you did this.
So what we get out here turns out go A, B, C down.
Yeah, it's just those are your values of A, B, C. Yep.
Thank you. I didn't
What?
see that already.
What's that?
So once we get those, would you just throw them back to the standard one?
There's your A, B, and C. So what you're doing is you're using what's called an inverse matrix. By pressing the inverse button, that's the x to the -1 button, it does all this, it finds what's called a determinant and then it multiplies it through. It does a lot of what's on that back wall, that sheet of paper that's hanging there that just looks awful. Not for picture, but I I'm sorry. Hey, I didn't do it. I told you I wasn't going to.
I thought that's what you meant without even reading that.
And now, again, I'm going to go with alpha zoom, change it back to a 3 by 1. It'd be really nice if this thing was a little bit quicker to use. 5, 3, 9. X to the -1. It's right underneath the map button. That's your inverse button. And that gives me my values of A, B, and C. A, B, C in the column.
It gives you A, B, and C like in order?
Yeah, that's the whole point. That's why we do these. So that's A, B, and C. So that means my final answer would be y equals 1x squared minus 1x plus 3, or x squared minus x plus 3. And there's your answer. That's it. Yes, sir.
You put the coefficient things in the order with A, B, and C.
What do you mean? If you put the each,
The 3 equations.
if you put, as long as you put them, as long as you keep them with the right answer. So if you put this 9 up front, if you put that on top, so it was 9, 5, 3. If this 9, 3, 1 was across the top, your answers will still be 1, -1, 3. So the order, as long as they still match up to what the original equation was, that's still going to be your ABC. It will work. Because it determines. Because when you multiply, it's a whole matrix thing. At the very end of the year, if we have like a week or so left, I'll show you guys how to do this. But for all our intents and purposes, if we just sit there and know how to use the calculator the right way, it makes life easier.
Yeah, you just do it.
Hey, if you want the charger, or if you want to take a plug home with you, you can take that plug that's on my desk, and you can just plug it into your phone. Most of it is, yeah. Yeah, that's fine. Here, try this one. Do that one. So with any luck, then you got 3x squared plus 7x plus 1.
America's like, no, bears. America's just that one country that uses the metric.
How did I get what? How did I overwrite it? Alright, homework wise. I put it on the calendar already. I believe it was. Yeah, I put it in earlier. And so this is 5.8 in the old book. I had it on a post-it note right here. I have you guys doing 3 of each style. Yeah, those were on those. I found these 2 bracelets last week and nobody claimed them, so. Anybody need a bracelet? There's 2 of them, they're fancy.
Oh, how'd you make this one for?
I've had them for a week, nobody wants them.
You should wear them.
No.
You don't know where oh my god, really?
Whatever. Doesn't matter to me. Alright, work on those. Yeah, you saw how fast it is to start the first ones. I mean, honestly, it'd probably be faster to do the matrix ones first because you can put them right in the calculator and be done.